So for what we're talking about here with the project, it's the counting of the candy. And you're going to use these data for the next 3 projects. And the projects, you may want to print them out and do them by hand. You don't have to, but this one you don't need to print out. So if you happen to take pictures of the candies, it's kind of, I'm an organization person. I mean, you can see that in the background, right? That's all one piece, the same color. It's fun. You can put those pictures here. If you forget it, don't freak out. I'm not super concerned if you make this up. It might be kind of obvious if you do, to be honest with you. But you're just counting the number of M&Ms in your bags by color and keeping track of the total. That's it. That's the first thing. Without this, you can't do any of the other projects. So if you got your bag of M&Ms or your bag of Skittles, count it, you're done. For this piece, you can submit it here, which is day 11/7, which is today, and then it's saved there and it's not lost. And if you lose your paper, whatever, it's here forever. There was one other thing on there I wanted to show. Oh, remember, you'll need to download the thing as a Word document in order to type in it. You won't be able to type on the screen. If you request edit access, you will be denied. Alana won't even bother to look at it because there's no, if you edit this, it changes it for everyone. So that's why we have it download. In this same spot, the formulas you saw today, where is, oh, let me go to the actual chapter 9. Is that where it is? Why do I need to even talk about it? We don't need to talk about it till the time comes to work on it. So let's forget that. Any questions? Everyone's happy with chapter 8 review? Okay. Have I paused long enough for someone to have the courage to say, can we do number 7? I don't think there's a 7 on there. Okay, if you're happy, let's do this. I said this with the morning class, so I know I'm repeating myself, but I think you should take out your reference sheet and turn to page, let's see if I get it right, 274? Close. 272. So this is the summary of what you learned in the notes yesterday. Just the overarching summary. So this is the reference sheet. You wouldn't have written on this or anything, but maybe you did. I don't know. And you're going to use all this information to answer all these questions. So let's start with me asking you some fun questions. Does anyone know what this thing is? Should I zoom in a little? I'll read it. It's plus or minus z subscript alpha divided by 2. Anyone know what that is? Or anything about it? And it's totally fine if it's completely foreign. It isn't. Hint, it isn't. You've seen it in 2 places. How about I ask you this? Does anyone know how to calculate?
Z-score?
Yes. Okay. Okay. Good. So this is a z-score. Yep. Love it. That's important information. So typically, where we first saw this was chapter 7, and you saw something like this. Do you remember what we did with that?
Ignored it.
This was, let's see, left tail area or right tail area. If I were to draw the graph of this z-score on the, wait, what was it called? The normal curve or the standard normal curve?
I think the normal curve.
Close, add standard to it, and you got it.
Standard, okay. Standard normal curve.
So the reason we called it standard normal curve, there was something special about z-scores and their mean and standard deviation. You all remember that?
Yeah, one is 0 or 1, and the other one was, it would give it to you.
You got it.
Standard.
Excellent. So when we're working with z-scores, when you see this z alpha divided by 2, and when you saw this back in chapter 7, you understood that in StatCrunch you were going to use a mean of 0, standard deviation of 1, and that anything written here, if it was a plus, it was right tail area, and if it was a minus, it was left tail area. Well, now we give this thing another name. We may have named it that back then as well. I can't remember. Now we call this a critical z-score because it's that important. And really all of chapter 7 was to help you understand this tiny thing. A critical z-score. Okay, so what's the connection between confidence level and alpha? You know, here I'm saying all this stuff, and look at this. Page 271, in big and bold, critical z value. Did I say score? I should have said values. Critical z values are these, and we're going to find them in StatCrunch. And the C level is the area between the two values, and the tail areas are the alphas divided by 2. How we doing? Is everyone excited? Oh, I keep forgetting the chat. Oh, I see lefts and rights and critical somethings. Yes, look at all that. Love it. Okay, so why am I saying all this stuff? Well, we're supposed to compute the margin of error when we know the standard error is 6.7 and the confidence level is 88. Yikes. Like, how are we going to calculate this margin of error of a confidence interval if we just know the standard error and the confidence level? You go to the margin of error formula. Does anyone know how to read these two things? Like, what is z alpha divided by 2 called? How about the other one then? What's the SEP hat?
Standard error.
Love it.
Sample proportion.
Nailed it. Standard error of the sample proportion. Hey, doesn't this look suspiciously familiar? Let me just scroll up just a little bit. Did you all remember chapter 8? Dun, 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 dun. That's the spread. So now we get to use it. Okay, let me set the stage of what's happening. Chapter 8 is the theory that gives us the foundation to do what we're about to do. It's the why we can do it. And it gets a little weird because in chapter 8, we said, here's the population value. The center of all the samples that we generate will have a mean that's equal to the population value and a standard error that is equal to this formula that includes the population value. We rarely, if ever, know the population value. What we really want to do is take one sample and know the population value from that sample. That's what we really want to do. So this is the theory that says, if these conditions are met when we draw our sample, or all of our samples, this is what's going to happen. Now, what we're going to do is say, we're going to draw one sample, and because of this theorem, we can infer something about the population. And the first thing we're going to do is create a confidence interval. And in that confidence interval, we're going to calculate a point estimate that is our best guess at the population. And then, based on how confident we are that the sample will contain the population value, that's how we get the critical z-score, we're going to create a confidence interval that bounds our point estimate and says the real population value is somewhere within here, somewhere between this lower limit and this upper limit. So, is this ringing bells? Is this just getting you pumped? So the confidence interval is a number line, right? And it can be written as lower limit, upper limit, and then right smack dab in the center is this point estimate. The thing you've just been asked to calculate, called the margin of error, is the distance between the center and the upper limit, margin of error. And it turns out that that's the same distance between the lower limit and the point estimate, right? The point estimate's exactly in the middle of these limits. So what you're calculating is the up and down values for the confidence interval. And we can calculate it by taking the standard error and multiplying it times, we never established what this was in words, the critical value. So we need two things to calculate the margin of error based off of this formula: standard error, critical value. Let's look at our problem. Do we know either of those two things?
Oh yeah, the standard error is 6.7.
Nailed it. We know one of them. So what's the other one we need? Let me write it out in words. The margin of error, which we're calling the ME, is equal to the standard error, standard error times the oh, it was written the other way around. Is that okay that I put them backwards? Times the critical value. So we know this one, standard error, yep, is given to us. Do we know the critical value? Trick question. Can we find the critical value? That wasn't a trick question. You're right. We don't know it, but can we find it with the information that's been given to us? The answer is yes, but how? How would we find it? StatCrunch and chapter 7. And this is how we're going to find it. We just need to know the confidence level, smash that in as the area for a between probability, and we'll get the plus or minus z alpha divided by 2, also known as the critical z values. Oh boy, my poor babysitter. My little girls have not stopped talking from the moment she's walked in.
So isn't the confidence level the center of the?
Yes.
Okay.
And they gave it to us, right?
So you gave it to us already.
So we're just going to convert this to 0.88, toss it in as a between, and we will know the critical z values. If this will log in. Okay, here we go. Here we go. Just like in chapter 7, by the way, this is the whole point of chapter 7. This is the whole reason we did all that mess in chapter 7, was so that we could go to calculators, the normal calculator. We could note it's a z value that's a critical value. So we'd leave the mean as 0 and the standard deviation as 1. We use the between option and we smash in the 0.88 as the area, and Shazam, we've got the critical z values. We've got these. If you remember the formula, it said z alpha divided by 2, meaning the positive one. We don't use the negative one. So it's 1.555 if we use 3 decimal places. And margin of error is just the product of those two things. How's everyone feel? Like whiplash, or it's making sense, or?
What you just did made sense. Where's the 6.7 coming in?
So they gave this to us, and our formula is multiply the critical value times the standard error. Let me show it how it's written in your reference material, because it didn't use words in here, right? This is it. The critical value times the standard error. This is how you can calculate the standard area if you know p hat and n, which we don't know. So instead, it's been handed to us. So if I write it in the order that it's written in the reference sheet, here's the critical value, here's the standard error, smash that in a calculator, you've got the answer. So let me rewrite the formula down below in words. Sometimes words are nicer than symbols. I don't know. Mathematicians prefer symbols because it's less writing. Takes up less space on the page. Great question, Hope. The margin of error is always a positive number because it's distance. That's what it's measuring. And if I go back to this page, the margin of error is this distance between the limits and the center. So up here, positive, down here, positive, because distance is always positive. So, I mean, if you put the negative one there, it doesn't matter. Just make sure your answer is always positive. That's the important part. Because it's distance.
But if they did not give us the standard error, we would need to do the calculation of calculating the p hat and the q hat over n to get it in order to finish the problem. But they gave it to us.
Right. If they gave that to us, then we could do that. Yes. Now, really, this is just helping you look at the margin of error, see one of the ways it's calculated. This is not a typical problem. This is more seeing the little behind the scenes things that are going on. So let me give you like 3 minutes to try the next two. I'll check in. If that's not enough time, we can take longer. Set a timer for 3 minutes.
All right.
What worksheet are you guys working on?
Great question. This is, oh, and I didn't even say what this one is. So this is page 654,
Okay.
and it's the 033 worksheet.
I know, honey, I love you. You have to give me a second.
Are we rounding these answers?
Another great question. So I rounded this number to 3 decimal places because that's pretty typical. And then it doesn't say here, typically we tell you what to round to. So for whatever reason, this worksheet doesn't have that. So you can round, oh, yeah, you can round to whatever you want. Okay, did you all have enough time? How about I just write down the critical values? I'll stay with the same order, critical value first. So I'll just write the critical value for this one in parentheses here, and you all can agree if you have the same one. And then I'll write in the standard error. That seem like what y'all had? Anyone have any questions on that?
That's what I got.
Nice, nice. And then the rest of the parts just calculator work. I hear there's a I don't know if you all know Doc Ott. That Z alpha number, that critical Z value, we're taking the confidence level from here. And that is an area that's in between the plus or minus alpha divided by 2, the 2 critical values. So we're just in our StatCrunch thing, typing in 0.9 in this case. And there's our 1.64. I rounded it to 3 decimal places. That's why it's 1.644, 45, because the 9 after the 4 changes it to a 5. And then the same thing for the 0.99, 2.576, because of the 8 after the 5. Does that make sense, Alexa? I'm assuming Z, okay. Cool. Do you all know Doc Ott? He's the chemistry professor. He always writes on these, who the F cares? Who the F cares, I guess, for calculator work. Because for him, he's like, yeah, everyone can type this on the calculator. I'm like, oh yeah, okay. He has a reputation of being tough, and he has shared with me that that's his persona because he is preparing pre-med students, is the main chemistry course he teaches, I think.
That's kind of stereotypical. Not everybody's doing that.
Right. There is an argument out there about weeder courses and what's the point of them, and are we really, like, this is a weeder course for the nursing department, right? And so I should be super tough on you all because, you know, if you can't make it in this class and you can't make it in the nursing program, and I'm like, you know, maybe the only thing is true is that I need to be as stringent and tough as the nursing department is. I don't know.
How many of us are going to be nurses?
Not me.
Probably
And you
half.
know what I mean? What are the statistics? What are the statistics on the students in your course actually go on to be nurses?
I don't know that. I do
That's-
know that a lot of students that are in stats classes and in mine are taking the class because it's a prerequisite to get into the nursing program. And the nursing program rates this as the second best indicator of student success in nursing. So if you get a 4.0 in this class, you're what, 10 times more likely, that's a made up number, by the way, to succeed in the nursing program than someone that gets a 3.0 or a 2.0. Not because any of the knowledge of this course helps you, but because of the amount of work you have to do to succeed in this course, I think.
Yeah.
Right? Like, and the nursing program is rough. Like, I've heard there's an 8-hour lecture class.
I
8 hours.
tried nursing. Yeah,
Did
I
you?
tried it. It's not for me. No, it's hard. This is hard.
tough.
It's like this all the time, nonstop, but you know, full 16, 17 hour credit load. Yeah, no.
plus clinicals, plus blah, blah. I mean,
Yeah,
I
yeah,
get that
no,
you need
no.
to be tough because like you could literally kill people, right? But tough for toughness sake, I don't know. I don't know. Okay. Cindy, did I cut you off?
Yeah.
No. Okay. Anyone have any questions on this? Are we all okay?
Oh,
This
cool.
is the distance between the center of our interval and the upper limit and the lower limit. If we knew the center, we could find the confidence interval. If we knew one of the limits, we could find the center and the other confidence interval, but that's not a common thing. Nice, Misty. That's a when my wife was looking at being nursing, all of the hospitals in Virginia were requiring RNs to work at the hospital. No LPNs allowed. I don't know if that's happened here in Michigan yet, but then like for the program she applied for, there were 24 spots and 900 applicants. And so then you got like the administration of like, how do you decide who gets in? Well, if you get a 4.0 in this class, that cuts the group in half, right? Or I don't know. Okay. So how about this problem? Yeah, my mom has been nursing for like 50 or 60 years. I don't know how long it's been. And she's like, yeah, at one point they required LPNs and then they backed it off and then they upped it again. And and you look at now, the hospitals are incredibly short of nurses. So maybe we now hire some LPNs. I don't know anything about any of that, so I shouldn't open my mouth at all. Okay, so here is a look at the confidence level. This is to help you understand what we mean by confidence level. Okay, so where does this come from? How is it used? What does it mean? Nice, man. If I wanted to make tons of money, I'm in the wrong job, right? Okay, so this is a graph of a bunch of confidence intervals. In fact, it's 100 valid identical polls. Okay, so we've taken 100 samples, all of the same size, and we asked them some question about an issue, like, is candy awesome? Yes or no? I don't know. And so, oh wait, what this is saying is the P, is the population percent, the true value of what everyone thinks, or what percent of all people think this particular way, is it within the confidence interval? This is saying the red ones are no, and is that aqua ones are yes. So I'll give you 3 minutes to think about this. Your job is to figure out how many polls do not contain the P. And then what would the confidence level be based on for all of these polls? So let me just give you 3 minutes. Set a timer for 3 minutes so y'all can think and read and all that. Okay, that was 3 minutes. What'd y'all get? How many are outside or don't contain the true value?
5.
Nailed it. By counting these 1, 2, 3, 4, 5. So if you look at what each one of these are, right, this red one, if we take this first one, this is the upper limit, and this is the lower limit. So whatever this is on the really high value of 52% of the people in this sample said yes. And on the low end, it was like 47% said no, or said yes. Yikes. And then in the middle is what, 49%? That's how we would read this. Hey, there's an election day tomorrow, right? So maybe this is who you're going to vote for. And I don't know who all of the candidates are for governor, but there's Whitmer and is it and Tudor, or is it Dixon? I haven't, and I know Whitmer because she's the current governor, but her running mate, whatever. So let's say this was Tudor is who we were talking about. So based on this, Tudor's going to win if the upper limit is the correct proportion. If it's not, if it's on the lower limit, we don't quite know who's going to win, except that if we look at the like if there could be overlapping on these with the margins of error. Okay, so 5 of them don't have the true percent of the population that's going to vote for Tudor, if this is what we were working with. So what's really going to happen tomorrow is 45% are going to say we pick Tudor as governor. 5%, or sorry, 5 of our samples don't have that 45 in it. 3 of them put it above the 45, 2 of them put it below, all the rest contain the actual value. And this is exactly what the confidence level is about. There's a mathematical proof of why this is true. So I'm just going to tell you the answer. Or did you all know the answer for B? Did you all know it was 95%? So this is 5 samples, but it could also be looked at as 5% of the 100 samples don't contain the 45. Whereas here, 95% contain the actual correct proportion. And this is where the confidence level comes from. We picked this to say, how confident do we want our sample to contain the proportion, the true proportion? And what we're literally saying is, of all the samples we pick, 95% of them will have the true value in it, based on that critical value. Now, here's the kicker. We're gonna conduct this poll, and we're only gonna take 1 sample. How do we know this isn't the sample we got? We don't. We just know there's a 5% chance that our sample is totally wrong and doesn't have the population proportion. So I don't know if anyone's thinking like, well, why don't we just make 100% confidence level? I can't really answer that other than it's impossible to be 100% confident when our sample isn't the same as the population. There's some math behind what happens if we have 100%. And there's some stuff we'll talk about with hypothesis testing that helps maybe explain some of the 100% stuff. It's the nature of the game. We're just big guessers in the stats world. Questions?
So where did the 52%?
Oh, I made this mess up. I'm just trying to read from the graph.
Okay.
I was just reading this one particular confidence interval, and really it's not 52, it's really probably 53, right? Because it's slightly above the 52.
Okay.
So where'd you get the 95% based on the P?
So there were 100 samples. 5 of them don't contain the true P. 95 do. So if we do 95 divided by 100, that's 95%.
95.
I'm
Okay.
glad you asked that. Thank you.
And Patty, that was on 209 in our notes.
Okay. Thank you.
Oh, yeah, yeah, this is the spot where you saw it in the notes.
Right.
Here's the description of what these two things are.
That's the
So-
only reason I knew it,
Nice.
because I looked at what we did last week.
So sea level is the ones that include the true value. Alpha is the ones that do not include it. And we're going to use this interpretation when we interpret confidence intervals in a few seconds. Okay, so let's get back to the next question. And that is 9.2, worksheet number 2. Okay, nope, 9.1, worksheet number 2. Let's not get ahead of ourselves. So this now, I'm going to give you a little bit, I'm going to redraw that picture and see if you can't answer 3, 4A, and 4B. So I'll just remind you of this. If we were to draw a number line of our confidence interval, the first number on it would be the lower limit. The top number would be the upper limit. And the middle number would be a point estimate. Does anyone remember what we mean by point estimate? What is it? Have you all learned that? Control F, point estimate. Oh, well, that's compute it. Well, that's not helpful. Where's the definition of it? Yeah, it's not on here.
Yeah,
So is this the first time you've all heard point estimate?
no,
Oh, then what is it?
yeah,
No worries. I'll remind you. It's the sample statistic.
Yeah.
That's redundant, right? Why am I saying sample statistic? It's the statistic, which remember from chapter 1, section 1, day 1 of this class, that was the first thing you learned, one of the first things. What are the two options that we study in this class? Right now, we're working with p hats. Tomorrow, you're going to learn about x bars. And then when we do the review, it's going to be all jumbled together. Okay, so the margin of error then is the distance between the point estimate and the upper limit. It's how far apart these numbers are. In other words, it's like, here's our sample. We guess it's this, but really the true value could be somewhere in between here. So try 3, 4, and 5. Set a timer for 5 minutes. So how are we doing, y'all? You feel good about your answer for 3? Or totally lost?
I've lost.
I think I got 3 okay, but 4, no.
Okay, so let's start with, my alarm's gonna go off here in a second. Can anyone identify the point estimate in 3?
Is it 0.14?
Nailed it. Now, how do we know this is a p hat and not a p?
It was in a recent survey.
Yes, in a recent survey. That's the only clue. Otherwise, the language we used in chapter 8 was the implied all. But instead, this is implying some, because it came from a survey, and there's no way they surveyed all people, all millennials. Especially if they tried to call them. I don't know who counts as a millennial anymore. Okay. Did you know what to do with all that? What did you do, Patty? You got it. Tell us how you got the answer.
I added 2.5 to the 0.14 and got a positive 2.64 as our upper. And then I subtracted 2.5 from 0.14 to get the lower, which is a negative 2.36.
Really, really good, except for one tiny thing. You mixed your symbols.
Okay,
So either you need 14% plus 2.5%,
right.
or 0.14 plus or minus 0.025. So for one of them, you made the 14 into a decimal and then added to it a percent. That's what
And that percent, I need to switch that to a percent. Okay.
Either have them both as percents or have them both as
Yeah.
decimals. Doesn't particularly matter which. I think StatCrunch prefers decimals, but I could be wrong. So 2 answers we could have here, which is totally right. We want the margin of error gets added to the point estimate to get the upper limit and subtracted from it to get the lower limit. So 14% plus 2.5 is 16.5%. That's the upper limit. 14% minus 2.5% is 11.5%. That's the lower limit. If we wanted that as decimals, just 0.115 to 0.165. So what this means is, in our sample, 14% of millennials said, hey, we're not going to get married because we got too much debt. But if we're wanting to apply that 14% to all millennials, what we would say is, hey, our best guess is that 14% of all millennials are delaying marriage due to their debt, presumably credit card or student loans. But really, it's between 11.5% and 16.5%. That's really where the true population proportions is. Our best guess is 14. That's what we got from the sample, but it could be anywhere in between those numbers. Now, the only thing that's missing from 3 is the confidence level. The more confident we get, the wider our interval has to be. The less confident we get, the more narrow our interval can be. Like, I can tell you, I'm 100% confident that the average grade, or the mean grade for this class on the final exam is going to be between 0 and 100%. And that's because my interval contains all possible values. I've said nothing, right? Like, I've added no information to the criteria. But maybe I'm 95% confident that the class mean will be between 70 and 90. Okay. Remind me, what's a point estimate?
A statistic.
Good. What statistic are we talking about in number 4? Proportion or mean?
Proportion, because there's a percent.
Okay, that's what they said this morning. And that's what we used to say back in chapter 8. Now there's a problem.
Dude.
This- I know, right? I know. This percent is a special percent. It's the confidence level. So I'm going to scroll down to 9.2 and I'm going to show you something in 9.2. Because 9.2 is about the means. Let's see. Let me find it. Wait for it. Wait for it. Wait for it. Hang on, we're getting there. Oh, they don't have a nice problem like that where it's like in there. So one of the nice things about means is we give you a data set and there you go. But look at this. Here's a percentage in a problem that says calculate an interval for mu. So here you have to be careful with the percent. If it's attached to the word confidence interval, it's the C level. It's the confidence level, which is weird too, right? Because why don't we say 90% confidence level for a confidence interval? Am I losing you all? Is it getting too crazy?
A little bit.
Yeah.
Let me scroll back to where I was. Part of the problem is just scrolling and the craziness of that. Okay, so what I'm saying is when you see this percent and the words that follow are confidence interval, that does not mean, that says nothing about what type of point estimate we're working with. So what's the other clue or the other thing in the problem that clearly states this is a proportion and clearly might be an overstatement?
Is it because it's a survey?
You know what? That's a really good answer that I've never thought about before. 100%, yes, because a survey is going to ask you probably yes or no type questions. I guess the one thing is if the survey said, how much do you weigh? And so all the answers were weights, then it wouldn't be a proportion. Unless it was the percent of people that are under a certain weight or over a certain weight or equal to a certain weight. But yeah, anytime typically when we use a survey, that's going to result in a proportion. The other clue is we gave you the sample size and how many out of that sample preferred something. That's success. Anyone remember the formula for p hat?
X over N.
Nailed it. Excellent. It's also here if you forgot. This is on the confidence interval reference page, page 272. I think we encouraged you to write that formula on your chapter 8 page because sometimes you need it. Okay, so then what's our X and N in the problem? Have they given it to us?
Well, N is 344 because that's a sample size.
Good.
Right.
Now there's 3 numbers left in the problem. It's either 4, 95, or 203.
Is it 203?
Yes, good. Yep. Why is that? Well, so, okay, definitely whenever we talk about decimal places, that number is just what to round to, right? Percentages are not X's. P hats are percentages. So when we do the division, we get a percent. That's a p hat. This is if you think back to chapter 6, when we said a binomial distribution, anytime we're working with proportion, that is a binomial distribution. The answer is either yes or no. In this case, success is high school students who believe playing soft music leads to better studying. We're told to round this to 4 decimal places. How's everyone doing on this p hat, this point estimate thing?
Fine if you know when to use it.
Nice. Okay, okay.
Yeah.
Is it getting drilled home that point estimate means statistic? Like, is that sticking? And really, point estimate means either a p hat or an x bar. Chapter 9 or section 9.1 is exclusively p hats. So there it's always a p hat was what we're looking for, which then means you should also just, when you think p hat, you should think x divided by n. Or know where to look for it. Go ahead.
You should think what?
X over n. This
Oh,
little
okay.
But we're not doing that right now. We're doing proportion, right?
Let me think. What do you mean by that? We're not doing x over n?
Yeah. Oh,
We
no,
did.
never mind. Yeah, never
Okay.
mind. Okay.
Okay, now shift gears. Can you find the critical value? Did you all find it? If you need a reminder of what you're doing, this is exactly what we did here. We just used a different name. We used the symbol. So how did we get these numbers, these critical values? Hope, I don't know. How'd you get that? No, I do know. That's not quite right. StatCrunch, yes. So did you type in 0.95 to StatCrunch on the between calculator and compute with a 0 and 1 as the mean and standard deviation? Does that make sense? Um, 95% is a very common, nice, good hope, is a very common confidence level. So every time you see 95%, the critical value is 1.96. This never changes. And you might find yourself having this number memorized after a while. 95% confidence level, super common. You know why? Do you remember the definition of unusual when thinking about a probability? Do you remember what that was? A probability less than 5%. Nice, LaShawn. Do you see it? Do you see it there? What's 100 minus 95? 5%. So we're saying it's unusual for a sample to not contain the true population value when we pick a 95% confidence level. It would be unusual for the sample to have that. That's why this is such a common confidence level. Okay, now you got to reach way back to chapter 8. It's been at least a week since we did this. Anyone remember the standard error formula or even what this is? If you're forgetting, my hint was reach back to chapter 8. So I'm going to scroll back to chapter 8 and see if there's a thing that says standard error of the proportion anywhere on the page. And then see if there's a formula that follows. It's the angry face one, because we know a p hat. I'm going to write the formula down, and then I'm going to keep my mouth shut for a little while because I've been talking too much, and see if you can't compute the standard error and the margin of error. If you think you're stuck on D, look at what you did for number 1. But let me write down the formula and see if you remember computing standard error back from chapter 8. Set a timer for 5 minutes. If you get done sooner than 5 minutes, let me know.
What?
We get it? Or do we need more time? How do y'all feel about Q hat being 0.4099?
That's what I got.
Yeah, that's
Nice.
what I got as well.
Good.
That's what I got.
good. Good. And then we know that N is 344. So the standard error of the p hats is equal to 0.5901 times 0.4099, all divided by 344. This morning, one of the morning students mentioned Desmos making it being kind of difficult to get this fraction in there correctly. And I showed them this trick that might be helpful for you all, because we need the whole fraction inside the square root. So if you're fans of Desmos, what I would encourage you to do is first type in the square root, then hit your division button, and now it's guaranteed that everything's within the square root, and you can just type your stuff in. It's a nice, handy little trick. And so we get 0.0265. Get what y'all had?
Yes.
If you didn't, I saw this happen in my in-person classes. If you didn't do that thing, or you weren't careful how you typed in your fraction, you could get something that looks like this, which looks subtly like it kind of looks like it's the same, but it's also not, right? The numbers are wildly different. So here the 344 is within the square root, here it's below it. So we don't want this one. That one's wrong. We want the first one we did. Okay, margin of error, what's the formula? Based on, well, how are we gonna find it? What'd y'all do?
ME equals critical value times standard error.
Love it.
Or
Yeah.
1.96 times 0.0265.
Nailed it. And that's some sort of number?
0.0519.
0.0519. Perfect. Okay. Were you able to construct the 95% confidence interval using the margin of error and the point slope? In other words, were you able to repeat what you did up here? Or did you want some time to think about that? You know what? Because you're going to do another worksheet that's a little more complicated, practice, let me just put it in here just in case you haven't had it. So the upper limit, I'll calculate these separately because sometimes the plus or minus gets in the way. The upper limit is the point estimate plus the margin of error. The lower limit is the point estimate minus the margin of error.
Right.
And that gets, well, that gets this little spot of where all these numbers are. Boy, I don't know what just happened in my calculator. 0.5382. Okay. And 0.642. Or if you prefer percentages, as opposed to decimals, this is 53.82%, comma 64.2%. Questions on that? So I'm going to start us back on page 209. When it says interpret the meaning of this confidence interval in the context of the situation, it means write this. We are 95% confident that the true population, and then instead of parameter here, put in the context. In other words, what is this proportion of? That the true population proportion of high school students who said that playing soft music leads to better studying is between these two percentages. Should I just type that? What is it? Listen to believes that playing soft music leads to better studying is between 53.82% and 64.2%. Shoop. One other option, instead of is between, you could also write is within. I'm also happy with that. So this or this, either one. Does that seem okay, y'all, or is that crazy talk?
I'd have to say this page feels a little better, not 100, but a little.
We're getting there, huh? We're getting there. Okay. Now, so then we'll toss the little more difficult one at you, and you'll decide how you feel. So then to this, sometimes this is the most difficult question. So we've got this interval, and this interval is where the true proportion is. So then we get a reporter claiming that less than, keywords, 62%, key number, of high school students think that playing soft music leads to better studying. Do the research findings support or contradict this claim? So I'm going to show you the scenarios that have been laid out for you, or that all of the possible scenarios you're going to face. So you're going to be given a confidence interval, or you're going to calculate it or something. And so there's this lower limit and there's this upper limit. And then there's 3 spots that your claim could be. So their claim is going to be some sort of number. And with that claim, you're either going to claim the number is either going to be below the interval. So this is the location of the number. Or it's within the interval, or it's above. And then the claim is going to be that either it's, so if we want the claim to be supported, if we say that the number is less than, which is what we just said, the number needs to be above the upper limit. Because then all of the possible values, every single possible true population proportion is below the claimed number, because the largest it can be, this is the largest possible population value, the upper limit. So for a less than claim, our number needs to be above the upper limit. For an equal to claim, which tends to be the simpler one to keep track of, the number just has to be within the interval. And for a greater than claim, or any version of these words, right? I guess I should have said equal to here. Any other word that is similar to this, your number has to be below the lower limit. Because if we're claiming that the true population proportion is above a particular number, then the smallest possible value for the upper limit or for the lower limit, for the true proportion, has to be above the number. Okay. Should I pause here? Maybe I should pause here.
So you want us to tell you what we think is the answer?
Yeah, so what do you think is the answer back on that? Well, let's start, before you tell me what you think, where is this number relative to our confidence interval?
In the middle.
Okay, now, is the claim supported or not supported?
It does not support because he's
Because?
saying less than.
That's
He's
it.
claiming that it's less than 62%, but it would be a contradiction because 62 is inside the interval, which would be in the middle.
That's it. There are numbers, there are possible numbers that are above 62 for the true proportion. Some people look at the 53 and are like, oh yeah, 62 is above 53. So, you know, it doesn't contradict, it supports. But that's not what you look at. You look at the entire thing. I'm borrowing this from Cindy from this morning because it was such a good point. You're looking at the interval as a whole. And since 62 is not below the largest possible number for the population, it's contradicting because of that less than claim. So there are 6 options here, 6 possibilities of what could happen. When we get to chapter 11, it's super straightforward. Is 0 in the interval or is it not? Here you have to track the number and the location. I should say, so the location of the number and the claim about that number. And then from there, you determine, does it contradict or support? Okay. So let's test this. I kind of like this problem. So let's jump. Well, maybe we shouldn't. Let's just take 5 minutes and see how you do with this. So we're kind of back to stat crunch for number 1. We're definitely back to stat crunch for number 1. And note, we're looking at critical Z values and just computing them. Can you stat crunch these critical Z values? So let me give you 5 minutes and we'll see how it goes. Set a timer for 5 minutes. Okay. How many critical Z values? 1, 2, or 0?
2.
Yeah, that's the point of the plus or the minus. In fact, that minus is where the lower limit comes from, and this plus is where the upper limit comes from. Nailed it. Did you all get 1.4395 for B?
Yep.
Good, good, good. Did you get 0.1764 for C?
Yes.
Ooh, uh-oh. Do we use alpha or the C level?
C level.
So, I didn't give you all this. This was unfair of me. I didn't remind you of it or whatever. The C level is equal to 1 minus alpha. So what we really need to use is 1 minus 0.14. Because so if you think about what we would be saying if we put 1.14 in here, we are comfortable with a 14% chance that our samples have the correct, the true population proportion. Like we might as well not even bother, honestly, because most of them are not going to have the true proportion. So what we need is the 0.86. Even 0.86 feels pretty bad. Unless we're not spending a ton of money. Does that make sense, y'all? I'm sorry, I got tricky on that one. Did you get 1 plus or minus 1.4758?
Yes.
So there's a connection between C level and alpha. They are opposites of it. It's the same thing as P hat and Q hat. Same connection. One minus the one gets the others. What is it? Complements. Yes, they're complements. Which, by the way, answers D. What's the confidence level for these critical Z values we just calculated? Joke's on us. We had to have 86 in order to calculate it. Although it used to be we did like this, 0.14 divided by 2. And there's the 1.4758. Questions, concerns? Don't feel bad if you got caught by this. That's a common thing. Trick you once, shame on, I don't know how that goes, but something about 3 times shame on you, me, I don't know. Okay, did you all answer number 2?
I did.
What'd you get for P hat?
0.60.
Good, or 60%, either one. And so what did you do with the 3.1%?
Added it
Good.
and subtracted it.
And subtracted it. Nice. Yes, yes. Remember, confidence intervals are a range of values, so you must always have 2 numbers. I believe this is what's on the ballot tomorrow, right? This is one of the, this is essentially what Proposition 3 is about, although I'm probably way oversimplifying it. There's a lot of incorrect language out there about it, by the way. This, is that what y'all got? 56.9?
Yes.
That's what I got.
Awesome, good. I was trying to do that in my head. That's always scary. I can't tell you how many times people are like, oh, you're a math teacher? Hey, can you do these numbers for me? I'm like, no, I'm not a calculator. Use your calculators, love it.
Can you do the calculation on that? Because I'm not getting it.
Okay, definitely. 60 minus 3.1. Did you do 0.6 minus 3.1?
No, I won't tell you what I did.
Okay, no worries, no worries. As long as you know what you did, that's totally cool. That's totally cool. Did you notice that this problem was exactly the same problem
Mhm.
as this one? Hey, they were even both 3s. different context. We changed the numbers a little bit, but the same idea. This tends to be the problem that's missed on the final exam, because we do a lot of emphasis on smashing stuff into StatCrunch and getting the confidence interval from StatCrunch. And students forget that if you know the point estimate and the margin of error, you can put the confidence interval together right there. That's all you need. Just add and subtract the margin of error. So now we're going to do a confidence interval in StatCrunch. But first, let me pause myself for 2 minutes and you all find the point estimate for the proportion stated in question 3. Set a timer for 2 minutes. Oh, my mic is still on. Okay. Anyone get what the point estimate is?
0.5498.
How'd you get that?
Divided X by N.
Ooh, and how did you
558
find X and N?
I guess. No, I'm just kidding.
Cindy said so. That's the other one.
Right, Cindy said so.
You're right, by the way.
Because 1015 was the sample or the population, and 558 was the sample, the number. Yeah, I don't know. I can't talk tonight, but
You're good. No, you got it. So I'll fix the language a little bit.
Thank you.
1015 is the sample size.
Sample size, yes. Sorry.
So that's the total of the
N
sample.
equals sample size.
Nice. Yeah, no, you're good. And then 558 is the number that said it's too much parenting, or parents do too much for their young children. Good. And you just divided it. Okay, let's talk through what this is. I think honestly, this should, this is maybe the most straightforward part, because you just have to know what to smash into StatCrunch. But we do try to make it a little worse, because we say, please write down the formula, the substitution, and the result. So what's the formula for calculating the confidence interval? It's on page 272. It's also in your notes. This is what we mean. Either this formula, really this is the formula we're interested in, this one, which is just the point estimate plus or minus the critical z-value times the standard error that we calculated back in chapter 8. So p hat plus or minus the critical values times the square root of angry face. Should we make them happy faces? That didn't make it happy. So that's the formula. Now, the substitution then would be, what are all the numbers? If we were to smash this in a calculator by hand, what would the numbers be? So we'd need to state what's p hat. That's the 0.5498. What's q hat? That's 1 minus that. So 0.4502. What's n? 1015. And what's z alpha divided by 2? Now, we're going to get actually all of this from the StatCrunch thing. I think you probably did this at least once in your notes, maybe twice, but this is a good reminder. If you don't know where to find these things in the stat menu, the good news is we typed it out right here on page 272. So you're going to go to stat, proportion stats, one sample, and with summary. You were never going to do this with data because we never in this class give you a proportion data set. It would just be a huge long list of yeses and nos. And when you click that, notice there's only two things you need: number of successes and number of observations. Unfortunately, we haven't clearly labeled what these things are per se. So I told the morning class to do this. I'm going to tell you all as well. You might as well write here in your notes, write x equals number of successes. That one that's how we defined x. So that shouldn't be anything new. But I don't know that we've called in the number of observations. That's kind of new language. So if you think you're going to forget that x and n are the things that are being asked for in the confidence interval, this is a good place to write this. It's going to be the same thing when we do hypothesis testing, by the way. Because if you look, we have to decide what thing are we going to do, a hypothesis test or a confidence interval. So number of successes, that was the 558. Number of observations, that was the 1015. And then the confidence interval, we have to make sure we read it. This always is given to you. So we need to change the level to 0.90. And the method is always going to be the standard Wald method. There is another one. We're going to pretend that that doesn't exist and ignore it. And then because we want the critical value, we want to select this so that we can just copy it instead of having to use the normal calculator. Is that good for everyone?
Is that 558 or 5?
558.
Oh, okay. Okay.
Yes. Which begs the question, why did we have you compute the point estimate in A when what we need in StatCrunch is the X and the N?
Yeah, why did you do that?
Just to remind you of the point estimate. Because look, here's the point estimate right here, right? StatCrunch even calculates it for you. Because I'm a jerk, I guess. I don't know. So here's the output. And one of the things is making sure you can read the output. Note it gives us the X and the N like we typed in. It then calculates X divided by N. It then gives us the standard error. Remember, that's the square root of P hat times Q hat divided by N. So it does that calculation. It ran the normal calculator and calculated the critical Z value for us. And then it spits out the results labeled as L limit and U limit for lower limit and upper limit. So all we have to do then is copy down the critical Z value, plus or minus 1.645, and then copy down the interval, shoop, shoop, with the required decimal places. For this time, we chose 4 because that felt like a good number to pick. And because this is a proportion, we could also write this confidence interval as percentages if we so chose. So that would be 52.07%, comma 57.54%.
Can you show me one more time what you put into StatCrunch?
Most definitely.
Thank you.
So we went to stat, proportion stats, one sample with summary.
Okay.
And then we put in the X for 558. We put in the N, which is 1015. And in chapter 10, you will be doing hypothesis testing. And you'll have to figure out what HO and HA means. No worries, it's not too terrible. But for now, we're selecting confidence interval. And we had to change the level to match the one that was given in the problem.
That's what I missed. Okay.
Nice. It's defaulted to 0.95, and it's often that we use 0.95, but of course we're going to mess with it just to see if you're paying attention. And then don't forget, if you want the critical value, you have to click this critical value. I wonder what this confidence interval plot looks like. Oh, that's boring. And there you have it. Did anyone interpret this in context already? Oh, you know what? I didn't read that this morning. I went off on my grandma saying I did too much for my kids, but I missed the word young adult children. It had nothing to do with my grandma.
Better apologize to her, Eric.
I got to call her up and tell her I'm sorry.
Is it 95%?
You know what?
confident?
90%. Yeah.
Definitely 90. I need to call my grandma. It's been a while. Yeah, well, I'll give you that. I'll give you that. So this is like all the parents that still have their 20-year-olds living in their house, which is like all of us, right? I don't have 20-year-olds, but which is like just people trying to survive COVID and the economy and all the rest.
Hey, I'm impressed you let your daughters eat spaghetti alone, so I think you're good.
Let's just call that an experience. I don't think I got to do that one again.
I was so impressed by that, Eric.
You know, there wasn't that much spaghetti on the wall. Is that the difference between boys and girls?
Might be.
I don't know.
Having two boys, yes, I would say so.
I heard you people tell me my head was cut off. I just saw myself.
Oh,
Like, Patty, can't see you. Hello. Oh my gosh.
well, you are 2 out of 11 that have your thing.
I was gonna say, where's Becky?
Oh, I like that. Will.
Is this her week for Vegas?
Oh, is this Vegas?
She doesn't leave till Wednesday, I thought.
Oh, well, she's getting ready. She told us she had prep to do.
Gotcha. Makes sense.
Okay, we got 19 minutes. We're kind of in the same spot we were from this morning. Don't let me charge on. Did everyone get what they needed from question 3?
Mhm.
Okay, so I'm going to skip question 4 because I mean, it could stump you, so don't feel bad if you get stumped. It's basically, can you read the output? And I want to let you practice what we just did. And I like question 5, so I've jumped to page 658 because question 5 puts it all together, everything. So if you look at the confidence intervals for single proportions, there's the central limit theorem requirements we learned from chapter 8. Remember, the word verify goes with these. Show that we know these are true. So this question starts with that. Hey, make sure that when we construct a confidence interval, it's going to be meaningful by noting that these 3 things are met. So do that just like you did in chapter 8. Then this one is a little tricky. I'm just going to give you the formula instead of having you guess it. Here you're trying to calculate x. If we solve the p hat formula for x, we get this. Really, you're just saying
Gave
what
it to
percent.
them, Eric.
You
They
gave
already
it to
have that on their note
Oh,
sheet.
good.
And
Okay,
they
so I
have
need-
n solved already for chapter, not, 9.4.
Then
We're
I
ahead of
just
the game.
give you time. I just, yes, see, excellent. Okay, so I'll do 5 minutes. It's probably not enough time. I'll check in and we'll see how we're going. This is like an exact final exam question.
Oh, there it is, okay.
Set a timer for 5 minutes. So that was 5 minutes. I'm sure it's not enough time. Did everyone get X? Maybe we should check in there. Because you need that for C.
It's 1175.
Good. Is anyone stuck on any one of these? Random, independent, normal? I know everyone's got random. Well, independent.
Well, N is 1895, so
Did you note that we gave you capital N this time around?
yeah, it's
76.1 million.
So don't worry about that calculation. Just be like, yep, that's true.
So Eric, can I stop really quick?
Mhm.
On our quiz this week, I had a lot of people, not a lot, I had a few that said the conditions were not met if they did not give an exact population number and said that they couldn't say that it was independent because there was no population. So you guys remember, if this one there was, but if there wasn't a population, we could say, remember, that's the magic thing, and we say all.
I thought the same thing, but then I read the sentences again in the homework and it actually tells you it's independent.
Yes, and that one actually did say it was independent.
Yeah,
That
it
one on
said
the
random
quiz,
and independent. Mhm.
it did.
Yeah.
But if it didn't, you would do what Eric just did.
Yeah. And this tends to be what happens. What I remember is this tends to be what it is.
Absolutely. They rarely give you the population size.
And I kind of like it because it reminds it forces you to remember what we did in 1-1. Use the sample to define what the population is. Cool, good. And then did everyone say that N is greater than 30 for number 3? I gotta stop doing that because that's definitely the wrong thing. And maybe I'll start putting that in your heads. That's wrong because that's for means. That's the mistake that students make most often. Maybe because I say that. This is what you should be doing.
Mhm.
And really, once you type that, it's probably fine, but I guess it's worth saying what's the number. When you do your project, you're going to be doing a proportion thing, and there's a possibility that if your bag size is too small, this condition won't be met. That's okay. You don't need to recount or buy more things. Just note it and keep going.
Don't say that it's not normal and don't keep going. Just
Right.
keep going. So if you get that it's not normal, we normally say that we can't keep going. You just keep going.
Oh, really? Okay.
Yep.
Well, in the project, we told you to get a particular size bag. And sometimes people don't follow that direction. And then you will get too small of a bag, which is fine. It's like, I hate asking people to buy things because you already paid a ton for this class anyways, but the directions literally do say, even if the conditions are not met, because I'm sure there's a student at one point that said, you know, I can't do the confidence interval because the conditions aren't met. And they're bound for law school. So awesome. Good. You know, yes. Okay. Did you all get the confidence interval already? I'm just gonna put the answer down for the confidence interval and let you copy and paste the substitution stuff. So just as a reminder, proportion stats, one sample with summary. We calculated our X back in B. We know the N because we used it in the calculation. And this time it's a 99.5. So we have to change this to a 0.995. I'll show the critical value because you need that for your substitution, but here's the result. Oh, and this time we want 5 decimal places. Huzzah. So then what, we're 95% confident that the true proportion of all adults aged 18 to 33 who have more debt than savings is between 58.875% and 65.135%.
So on that, when it asks us to give the formula substitution and result, do we need to write that out every time, like write out formula, write out substitution and result, like what we did in our
So
notes?
Come on, Eric, say yes.
yes, that's what we're asking you to do. So I think the question is there value in writing this formula down? Let me show you the other formula you're going to have to pick between the two. And that, to me, that's the one argument of why having you write the formula down is useful. Because this formula for p hats looks real kind of similar to this formula for x bars. So it's another chance, if we force you to write the formula down, it's another chance for you to maybe catch, am I doing the right statistic? Am I thinking about the right thing? Am I thinking about proportions or am I thinking about means? And I've seen students try to solve a problem where they write down the mean formula and they're like, I can't find S. And it's because the problem is a proportion problem, not a mean problem. That's the argument for writing the formula down and the substitution.
So you can get partial credit if they write the wrong one down.
Good point.
Yes.
Good point. That's yes. I'll keep my mouth.
You got to say something good about it.
Yes. It's just yes. The goal is to get this output. Like that's the goal. But this is to help you get there. So then the substitution part, right, is just, did you figure out p hat? Did you figure out q hat? Did you figure out n? Do you know z alpha divided by 2? P hat we already knew from above, n we knew from above, q hat is that calculation, and the z critical value is here in the stat crunch because I clicked show it.
So that's where you're losing me a little bit, is on the substitution.
Okay, good. I'm glad you're telling me to cool myself. So I'm saying, what is this number? What are these two numbers? Well, this is a repeat. What is this number and what is this number? So we kind of know these from above, right? Didn't we calculate? We didn't calculate p hat. So I guess we don't know. Oh, we do. P hat is the 62%. We used it here. In fact, we also found q hat here. So we're just rewriting them. And then the critical value we got from here. And technically this one's rounded.
So Nicole, he's not really substituting them in right now. He's telling you what they are. So you know substitution means that you're going to take those values and put them where they go in that formula, like how we did it in the notes.
That's what's getting me,
Yeah.
because this is a lot different than what we did in our notes.
Got you.
So
Okay.
yeah.
I'm okay if you do it like this. I'm also okay if you substitute them into the formula. The one thing I've seen students do when they write it out like this is then they try to smash this in their calculator and inevitably screw something up.
I told them, don't even think about putting in your calculator.
Yeah, just don't. I mean, it's doable. One of the problems is this is misleading. There's no such plus or minus button in Desmos or your calculator. So you have to enter these one at a time. The reason I'm not as interested in you writing out the substitution is because of that. I'm interested in, the formula, the values. I assume you can substitute, but maybe I shouldn't. I don't know. And then you get StatCrunch to tell you the answer. Because remember, StatCrunch, all we had to do was enter two numbers, X, and N. Oh, I guess 3. And the confidence level. Whereas in Desmos, talk to me.
But in the, so in the formula, did you calculate so you actually did the,
I'm listening.
you actually did the calculation for
The critical Z.
yeah.
Oh,
It's in StatCrunch.
Oh, I was gonna
Yeah,
say,
let
I
me
don't know
show
where
you.
that was at, yeah.
let me show you that. That's a
I
good.
don't know why. This
I
is
don't
showing
think
off
I
so
did
bad,
it that way. I forgot that they could click that button, Eric. So I think we did the critical value separate, which
And that's fine
was
too.
fine because we were just learning how to do it. But yes.
Yeah, like
So you
up
guys
here,
click that show critical value button,
Right
which
here.
I didn't show you. And then it will calculate it for you.
like up here, you have no choice but to do what Cindy was showing you, right? Like we're like, hey, what are the critical Z values? Well, you don't know a P hat or an X or an N or anything. So you have to just go to the normal calculator and plug in the between and this thing to get it. But when you're doing a confidence interval, if you want to save yourself some time, you just click this show critical value and it's thrown into the table for you. But we could certainly go to stat calculators normal between and put in our 0.995, and there's the 2.807 that we used, that StatCrunch already gave to us.
So, but what you're writing, like your 62 plus or minus 2.807, you're just taking that from
Right
what
here.
your answers and okay.
I did bother in Desmos to type in the upper limit into Desmos. So 0.62 plus 2 point blah, 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 all this, and there it is. Is that the same answer StatCrunch gave us? Oh, it's different. Did I type something in wrong here? Oh, you know why it's different?
Rounding.
Because rounding. So let me type this in and we'll probably get the same thing. Whoops. This is the other reason to just let StatCrunch do it. No?
Yep.
Did that do it?
Yep.
Oh, this was rounded. Okay, let's change. This is the more important one. So let's change that to, oh, I got, what? I got the wrong, I got a 95% confidence interval. I never changed it. That's the problem. Here we go. Phew. So 0.65129779728. 0.6513. So the rounding does affect when we go up to 5 decimal places.
You guys just use StatCrunch. Don't worry about,
Yeah.
don't do what you just did in Desmos.
Don't do
Yeah,
that.
I'm just thoroughly confused of what to do at all here.
So the goal is to get this, what I'm writing right now. That's the point. When it says
Mhm.
construct this confidence interval, we're to find the lower limit and the upper limit.
Yeah.
So if you notice, we can get these two numbers just by plugging X and N into StatCrunch. That's it. So to make it a more interesting problem, we're like, please also tell us what the formula is that StatCrunch is using to calculate this. And please also show us the substitution for all of the numbers.
I think formula result is good enough. But I'm gonna be quiet.
I mean, I'm okay with just result. Oh, did I say it out loud?
I'm good with result. No, I think if they show formula, you would at least know if they're mixing up means and proportions.
Do you all like that? And really, maybe you should also write down, what did you smash into StatCrunch? What did you put in for X? What did you put in for N? Like, that's important information to use to get this. This stuff, StatCrunch spits it out. Who cares about all that, in my opinion.
So you're saying at this point, if we at least give you the information that we put into StatCrunch and then the results, you're happy?
Yeah.
Yeah.
When I
Especially if it's
grade
right.
these, I usually
That
only
relieves
do
me
this.
from having deers in the headlight right now.
I feel like I shouldn't have, but I am like just thoroughly confused by this.
You know what
I mean,
we're
it is
gonna do?
8:05.
We're gonna do like the chapter 9 flow chart tomorrow. So it will summarize all this tomorrow. You'll be fine.
Okay.
The thing that's happening here too is you correctly calculated critical z-scores here, right?
Right.
And you've correctly put together a confidence interval here, and you've been able to identify a p hat knowing X and N, and this problem just like smashes all that together.
You're fine, Nicole, promise.
You're
Okay.
fine. You
You're
guys,
fine.
you're totally fine. And I am really, what I most care about is that you can get the confidence interval. The only reason I say, please write down the formula and what you typed in is to help make sure you get the correct confidence interval. That's the other argument for why all this is here. Because it's forcing you to read carefully through the problem and find all the information that's there. That's the other thing with all of chapter 9 and 10, all of the information is there. There's maybe one thing you're missing, and StatCrunch gives it to you. You'll feel better after tomorrow and Monday,
Okay.
for sure. Because we do this again with means. Will that make you feel better?
You're not helping, Eric.
It will, you guys, it's
It
fine.
will.
You're gonna be fine.
You'll be fine.
Yeah.
Because the thing is with means, it's slightly different things, but it's the same overarching concept. There's a lower limit, an upper limit, and a point estimate in the middle.
Okay, so let him do E real quick. Is
Oh,
it
do E.
contradict more than 60%? If you look at your interval, more than.
I'll write out the interval in percent notation, if that helps.
I'm going with support, since 60% is within the interval. Even
Is
though
the
it says more than.
Is the claim that it's equal to.
Said contradict.
Because
It's within the interval.
yeah, look at the lower limit here. This tells us that it's possible the percent is 58
Yeah.
or 59, which is a number smaller than 60. So when the claim is more than, you're looking at the lower limit. When the claim is less than, you're looking at the upper limit. So in this case, it's a contradiction because 60% is within, not below the lower limit. Every single possible value for the true proportion has to be above the claimed value in order for a more than claim to be supported. It's tricky. You know, good work, y'all. It's late. A good night's sleep, and you'll wake up in the morning full of confidence intervals and confidence for how you're going to do on the confidence level. Are there any questions? Anything that's...
I don't know about anybody else, but for me, how my brain works is I have to look at it again
Night Peg.
and simplify it. You know what I'm saying?
Yep.
Yeah.
I've left you a problem to work on too.
Okay.
Number 4.
And I also don't feel good, so I'm like not.
Well,
100%
that'll
happy.
do it too. Go rest. Yeah.
I
And
will.
so if you don't have time tomorrow to look at this, we have time on Monday. And then we're still going to do a chapter 9 review of this stuff too. So you have one more section, so 2 more sections, 9.2 and 9.4.
Right.
9.2 is the same thing, just with means. 9.4 is calculating sample sizes, which is kind of a different little thing, but it's just formulas. And then we review it all. So we do it all again.
Mhm.
So if you're still feeling how you're feeling right now in Wednesday of next week, then we should talk more. And you should maybe be worried. But right now, don't be worried if you don't just know it all.
I'm not worried.
Good.
I'm just in a fog.
You're all right.
All right, guys, I'm going to bed.
Sleep
I'll see
good.
you.
Okay,
Yeah.
good night,
Bye.
Good,
Patty.
everyone.
Well, usually I don't like to be complacent, but I just want some complacency.
Night, Will.
So what does
I just
that
want to be
mean?
complacent. I don't
You
want to
just wanna
learn
be like-
anymore. I just want to do one thing and no more learning.
Yeah, I mean, that'll
No,
come
I'm
in
just
about
kidding.
3 weeks.
It'll probably come in a couple of days.
Yes.
That's
Yeah.
what always happens.
Just-
I look at this and go, "But, like,
I
and
mean,
then it
give yourself
comes."
some grace. This is really complicated. And I doubt you've ever done anything like this ever in your life.
No, and I hope to
I had-
never again.
I had a bachelor's degree in mathematics and a master's in math education, which doesn't, whatever. And I had never done this. Actually, I had done it. I just didn't remember it.
The very first semester I did this type thing, I did it with you, Eric.
Seriously?
And it was that when we went from in person to, it was COVID, we went online. So
Oh, boy.
yeah, and there was the first, so you guys, I was just like you. I had never done this. And I was planning on being in person, having Eric right there to hold my hand as I was doing this, because we were not scheduled to do a stat class. But I think one of our QR classes got canceled
That's right.
and they needed a stats. And I'm like, I've never taught stats in my life. What the heck? And then what is a hypothesis test and what is a confidence interval? And I'm like, so Nicole, I get you. I know exactly how you feel, but I love it. Like,
Yeah.
This is my favorite stuff ever now. Like, I live for this stuff. No, I don't live for it, but I love hypothesis tests.
The paycheck is kind of worth it, right?
It is. Well,
Kind of.
I like doing it. It's fun.
Right. Yeah.
Okay, I'll
Trust me, Nicole.
You
Trust
got
me.
it.
You got it.
I trust you guys.
Right. Nice